Welcome. In this explainer, we are breaking down a topic that is absolutely critical in software engineering, quality. Now, for anyone studying this, getting a handle on these concepts is non-negotiable, so we're going to cover everything you need to know.
Yeah, that's a pretty mind-blowing question, right? And we are definitely going to get to the story behind that number. But first, to really understand how a software bug can have that kind of impact, we need to look at another disaster, one that put the security of the entire internet at risk. All right, let's get into it.
So here's our game plan. We're going to start with a really important case study. Then we'll define what quality actually means, look at the staggering cost of getting it wrong, talk about how to manage it, and then wrap up with a hands-on method for building quality in from the start. This is the framework you're going to want for your studies. Okay, let's kick things off with a real-world crisis. This story shows perfectly why software quality isn't just some abstract idea. It is the bedrock of building anything secure and reliable. So the story begins with something called OpenSSL. Now you can think of this as the digital lock on pretty much every secure door on the internet. It was and still is everywhere. But here's the kicker. At the time, this vital piece of global infrastructure was being maintained by a tiny, underfunded team of volunteers. That detail is absolutely crucial. So how did this whole thing work? Well, the mechanism was shockingly simple. An attacker could send a little ping message, a heartbeat, to a server. But in that message, they could lie about its size. They could say, hey, I'm sending you something that's 64 kilobytes long, but only send a tiny bit of data. The server, because it never bothered to check, would send back the original data plus whatever else was sitting next to it in memory, up to 64 kilobytes worth. And that whatever else could be anything, usernames, passwords, even the server's own secret keys. And get this wasn't some new bug. It was introduced by a bad line of code, and then it just sat there for 2 years, completely undetected. That points to a massive systemic failure. When it was finally found, it was this mad scramble to fix everything. But even weeks later, a huge chunk of the internet was still wide open to attack. You know, the key takeaway here is that Heartbleed wasn't just a single mistake. It was a total breakdown of the entire quality process. There was no formal code review, which means nobody was really checking the code going in. There was hardly any testing, especially for these kinds of weird edge cases. The whole release process was just unstructured, and bad documentation meant no one really understood how it all worked. So, a disaster like that really forces us to step back and ask a really basic question. When we talk about software quality, what are we actually aiming for? Because it's a lot more complicated than just saying it works. Okay, for anyone studying this slide is key. You've got to know that quality isn't just one thing. There's the transcendent view, which is basically you know it when you see it. For a user, it's just fitness for use. Does it do what I need it to do? Then there's the manufacturing view. Does it meet the blueprint? The product-based view looks at its features, and finally the value-based view, which is all about balancing cost, time, and what you get for it. You can really boil all of that down to two main ways of thinking about it. You can judge the quality of the final product, or you can judge the quality of the process you used to build it. And here's a core principle of modern software engineering. A high-quality process is the absolute best way to get a high-quality product. You can't just hope to add quality in at the very end. It just doesn't work. Neglecting quality isn't just some abstract technical problem, oh no. It has a real, measurable, and sometimes unbelievable financial cost. Okay, remember that question from the start? Let's answer it. $460 million. On August 1st, 2012, that's how much money a firm called Knight Capital lost. And this wasn't because of a market crash or some outside attack. It was 100% because of bad software. And it happened in just 45 minutes. Can you believe that? A new software deployment went wrong. They pushed new code to 7 of their 8 servers, but missed 1. That one server left behind started executing old, buggy code that just spammed the market with millions of bad trades, almost bankrupting the entire company before they could hit the kill switch. This brings us to a formal concept called the cost of quality. You can split it into 2 buckets. The cost of good quality, which is stuff like training and testing to prevent and find bugs early, and then there's the cost of poor quality, fixing bugs before or after release. And here's the thing you absolutely have to remember. Money spent on prevention and appraisal is always cheaper than the cost of failure.
Knight Capital paid the ultimate price of external failure, and it was a lesson that cost them nearly $500 million.
All right, so if quality is a process, how do we actually manage it day to day? Well, it involves real quality assurance and also dealing with this constant, nagging problem that every single software team faces: technical debt. This is the classic definition, and the name is perfect. Think of it just like financial debt. You take a shortcut now to hit a deadline, which feels good in the moment, but you've basically just taken out a loan. And that loan has interest, which you pay in the form of slower development and more bugs down the road. And sooner or later, that debt has to be repaid. And this debt, it doesn't just appear out of thin air, right? It's caused by real-world issues. Pressure from the business to ship something fast, no process to keep things clean, no automated tests so everyone's afraid to change anything. All of these things pile up, creating a code base that just gets harder and harder to work with over time. So, knowing the problem is one thing, but how do we actively fight back? Let's wrap this up with a concrete, hands-on process for building quality in from the very first line of code. It's called Test-Driven Development, or TDD. TDD completely flips the usual way of doing things on its head. The cycle is simple, but it's incredibly powerful. First, you write a test for a feature that you haven't even built yet. Of course, that test is going to fail. That's the red step. Second, you write the absolute simplest, most minimal code you can to make that test pass. Now you're green. And finally, you clean up the code, make it better, a process called refactoring, and you can do it with total confidence because you know all your tests will catch you if you break something. And the benefits? They are immense. You automatically get amazing test coverage. You build this incredible safety net that stops old bugs from ever coming back. Debugging becomes way, way easier, because when a test fails, you know the problem is in the last few lines you just wrote. And maybe best of all of your tests become living, breathing documentation that perfectly describes how your system is supposed to work. So at the end of the day, quality isn't just another feature you can add to a list. It's not a box you check at the end of a project. It is a discipline. It has to be woven into the very fabric of how you build software, every single day. So the question isn't if you'll pay for quality, it's when. You either build it into your process from day one, or you just sit around and wait for the next preventable disaster.